Hello everyone, welcome back to the third lesson on collecting like terms. And what we're going to be doing today is we're going to be looking at powers and indices that may sometime get involved when collecting like terms. Now, if you don't know what powers and indices, I do have a video that will come up online soon, but just as a brief note on the side, a power, so I'm going to write powers. Right, a power, so if you have 2 to the power of 3, right, that 3 is your power, or is sometimes referred to as an index. Okay, and the plural for that, so if you have so many of them, then we call them indices. So that's your power, and that number there, we refer to it as your base. Okay. Now what this means is that we have 2 times 2 times 2. Okay, it's 2 cubed, okay, to the power of 3, or 2 cubed. Now that's all you need to know for now, but if you are interested in developing your knowledge on powers and indices, then I suggest you look at the lessons that I've made on indices. But for now, this is all you need to know. Right, back to the main subject. So I'm going to start with something simple here. We're going to start with just an x squared plus y squared plus another y squared and then an x squared here. Right, now hopefully most of us should really get this right from the first time, but I know some of us might get inclined in thinking that I can put all this together as 4x squared y squared. Now what's wrong with that? Now what you are doing is, or what this means is 4 times x squared times y squared. It's as if you're saying we have 4 lots of x squared and y squared, but in actual fact we only have 2x. We have an x squared here, another x squared, so that'll be 2x squared. So we can't really have 4x squared. We can't have 4y squared. So for that reason, this is completely wrong. So then what's the answer? Well, so I'm just going to cross this out, so what we know we don't refer to it anymore. Again, just collect like terms. So you've got x squared, so that'll be, we've got 2 lots of x. In fact, let me just change colours so we don't get confused with the above. You've got x squared, that's a positive x squared as well, so that'll be 2x squared. You've also got a y squared here, right, and that's another y squared there, so that'll be 2y squared, a positive 2y squared. Okay, and that's your answer. Now we're going to look at something a bit more complicated than that, and start on a new page, and say we have
8xy squared plus xy, take away 2xy squared, take away an x.
Y. Okay, now you can probably tell there are a lot of things going on. We've got an xy, we have xy, we've got squareds, powers, we've got numbers in front of things. What does it all mean? Well, I just want to remind you that, for example, if we take this 8xy squared here, what this means is you've got 8 lots of xy squared. So you've got, xy squared, you've got another xy squared, and so on and so forth, So you've got 8 lots of them, right? 8 lots of these. Okay, so this xy here has only 1. Now you might be thinking of, you know what, I can possibly add these up together and say, well, this actually equals 9xy squared, say, or xy, or something, I don't know, x squared, y squared, right? Could we actually do that? Well, let's break things up. if we just go to the left, to the right, sorry, here, and say, well, is xy squared the same as xy? So if you look at the left hand side, what this is telling us is that you have x times x, x times, change colours, x times y times y, okay, because it's y squared. Now on the right hand side you have just x by itself, so you've got x times and then the y. Now you can straight away see that you've got y times y here, but only one y on the right hand side, so they're not actually equal the same. But what we could do is we take this further just to prove it for ourselves for sure that this will not be the same. We could do this by substituting some numbers. So we can say, well, if x is 1 and y could be 2, so you say, well, that's times 2 and times 2, right? And on this side, you're going to have just 1 times 2. So I'm going to have 1 times 2. Okay, are they the same? 1 times 2 times 2, that's 4. And on the right hand side, 1 times 2 is 2. Okay, they're not the same. 4 doesn't equal 2. So for that reason, we say, well, this is all just complete nonsense, and therefore we're not going to act by this. Okay, so scribble it out. Now back to the first problem here. Let's rub this off. Okay, so how do we add it up then? So what we do is we look at the like terms and go, right, well, I've got xy squared. Do I have another xy squared? Well, I have one here. I've got a negative 2xy squared, and there's my positive. Remember, every term is positive unless there's a negative sign. Okay, so 8xy squared, take away 2, that'll be 6xy squared, and then you're left with the xy, positive xy here, and you've got a negative xy there. Now that'll be 0, because this is just a 1xy, that's a negative 1xy, just an xy. Take them away, that'll be 0. So I don't need to write 0 here. Now I hope you've enjoyed this series of videos on collecting like terms. If you've enjoyed it, give us a thumbs up. Let me know what you think of these videos, and if there's anything you want me to go over. And I'll be looking forward to seeing you in the next video.